I'm Dylan Jones.
And I'm Carson Jameson.
And for our project, we decided to make a set of resin chess pieces and a sheet metal chessboard.
In this process, we learned a lot about additive manufacturing, shape casting, sheet metal forming, and machining. So right now we are in the Fab Lab, and we have created several chess pieces in CAD. And we're going to use these chess pieces and 3D print them so we can use them as our negatives for our silicone mold. And then we could pour in resin into our silicone mold and create mass-produced versions of these pieces. After 3D printing the pieces, we decided that they were too large for the scale of the project we were going for. So we decided to buy our own chess set and use these instead. Now what we're going to use is a silicone rubber. It's a 2-part adhesive, and we're going to be mixing them in this cup equally and then pouring them over all of our chess pieces. So we're going to have one complete set as a silicone mold, and we're going to pour this over it, and then we're going to be able to use our resin to make copies of these pieces. So I just finished mixing a 1-to-1 ratio, and this is going to be the first pour of many on the chess set. Over here, and we're just gonna, you see they're all moving, but we're gonna recenter them, and that was the first pour. Cool. After pouring the mixed silicone into the chess piece set, quite a bit of it, we realized that the chess pieces float in the silicone, so we're gonna have to find a way to keep them in the silicone while also getting the mold. Okay, so we tried to do the chess pieces in the silicone without any base plate, but we found out that the wooden pieces float. So we made a tape bed, and we're gonna flip it over, see if they stick. And they do, so we're gonna go here. Oh, and one foot. Okay, so we're gonna retry dipping the wood pieces in because it didn't fit properly the first time. So we're gonna try it one more time. A lot of writing on this one.
Mm-hmm. Give the push.
A nice friendly push down. And hopefully underneath. Perfect. Okay, so now they're just free floating. And we're to check back on this in 24 hours. Okay, after waiting about 8 hours, the silicone mold has finally dried, and I have been able to remove 2 pieces so far. The molds look really good, and I'm just gonna have to get rid of the rest of them and then start filling them up with the resin. I was able to remove all the chess pieces from the silicone molding, and they look really good. So we're about to move to the epoxy stage. So I'm going to be mixing the A and the B together as well as some dye, so we get the white and the black pieces. And we're going to be mixing them with a 1-to-1 ratio and then waiting about 8 hours to take them out. Okay, so after mixing some black dye and the 2-part epoxy, I've officially filled all of the molds, and now it's just a waiting game to take them out. Here we have the finalized black pieces. Obviously, some pieces are not perfect, but we'll be discussing why very shortly. Now that the black resin is out, we're going to repeat the same process with the epoxy, but with the white filament, so we have our black and white pieces. Here we have a time lapse of me mixing the resins and the white filament together and pouring it into the silicone mold. As you can see, me running back and forth to get towels because I made a big mess. This time lapse is about 30 seconds. In real time, it took me about 30 to 45 minutes to do this whole process. These pieces ended up looking a lot better because I spent more time creating them. As you can see, all of the molds are full. Now again, we're going to be waiting for 8 to 12 hours.
Hey guys, so we have our 2x2 piece of sheet metal, but unfortunately it's too large to fit in the water jet machine, so we're going to have to use this hydraulic cutter and cut it to size. Yes. This one cut out to 14 inches. Yep. So next we're going to move over to the water jet machine. And basically how this works is you just input your image onto the computer and it's able to convert it into code and print it out onto a piece of sheet metal. Here you can see we're using a template, a pre-made template, just to practice and see if the water jet is able to etch in or design. One thing we noticed is that, unfortunately, the water jet seems to cut through the sheet metal rather than etch it. So for our application, it wasn't the best suit for getting that contrast we needed. So our backup plan was to use this 10.5 by 10.5 sheet of plywood, and we are just gonna go the old-fashioned way, draw out an 8x8 grid, and burn in the edges. Okay guys, so we just finished the chessboard. As you can see, we have our grid now. And the last thing to do is just chop off these excess pieces right here.
So here we have the final project. Obviously, they're not a perfect chess set, but I'm really proud of how they turned out. As you can see, some of the pawns don't have heads, and there's an overall roughness on the pieces. We believe that roughness is caused by the porousness of the wood from our initial silicone casting, and we believe the heads popped off or there wasn't full molding due to the small cross-section of the pawns.
That's exactly right. So you could see at the top of those pawns, as we'll see here in a second, there's a bit of narrowness where that top sphere just narrows down into sort of a neck. In hindsight, if we could go back, we would make those necks a little bit thicker to give our product a little more sturdiness.
Overall, I'm really proud of how this project turned out and really excited how we got to learn so much about all these different manufacturing processes. Overall, I had a lot of fun and I would do it again. Here's the contribution list. I hope you all enjoyed.